All right, so we're going to talk about writing polynomial equations today. The essential question is how do we write the function if we know the zeros? And really what we're going to get to today is really what math is more like in the real world. Then we don't have equations sitting around waiting for us to solve them. We usually have things we want the equations to look like that we need to model for. So we need to do a little bit of prep work in order to get to be able to do some stuff we need to do later. So I want to talk about these questions here real quick. So remember the square root of 81 is 9. What's the square root of negative 81? I'd really like to not waste a bunch of time here waiting. So you guys would speak up. 9. Yeah, and Connor, make sure you're typing stuff like that into public chat. Yeah, 9i. Right, so the square roots of negative 81, the square roots of negatives are imaginary, right? So they're on that I. So remembering that, and then I squared, what's I squared equal to? So might help to remember what I is defined as. So I is the square root of negative 1. So what's I squared equal to? This is something we did talk about, but we didn't talk about it a lot. What's I squared equal to? If I is equal to the square root of negative 1, what's I squared equal to? Brooklyn, what do you think? Chad, what do you think? What's I squared equal to? Not asking what you know, just asking what you think. Kenzie, what's I squared equal to? Jasmine, what's I squared equal to? Yeah, what's I squared equal to? We square both sides. What happens to a square root when we square it? What happens to the square root of 3 if I square it? I squared the square root, and I got 3 as my answer. The square root of 3 squared is 3. So what's the square root of negative 1 squared equal to? Negative 1, yes. I squared is equal to negative 1. This is something you need to know. Okay? When we defined I said, hey, you guys need to know what I is. You need to know what the square root of negative 1 is, defining it. Right? We made that up. Okay. So something you need to know. Okay. I squared is equal to negative 1. So what's 4i squared equal to then? Well, that means that's 4 times I squared. We talked about something like that on Friday where we pull those things apart, right, Jasmine? So which is 4 times negative 1. So that means it's equal to negative 4. Okay? It's not 4 squared I squared, Peyton, right? It's just 4i squared. Only the I is being squared. So we do not leave I squareds in answers. Okay? I squared is something that can be simplified. So if you see an I squared, you need to make sure you deal with it. Okay? Just like we don't leave negative exponents in problems, we always deal with those. Right? So then 3i times 6i. Remember, it's all multiplication, so we can do it any order we want, which would be 3 times 6, which is 18. And then I times I, which is I squared. So 18i squared, that's equal to 18 times negative 1. So 3i times 6i is negative 18. Okay? We're going to be doing stuff with I squareds later, so I want you guys to see how to manipulate those. And we do not leave I squareds as part of our answers. We always simplify them down to being that negative version of it, whatever, or the opposite of whatever we're talking about. Anything here with the I squared stuff you guys want to talk about before we move on? Makes sense, Elijah? Makes sense, Chad? Yes, I squared is just turned into negative ones, right? I squared is equal to negative one by definition. Okay? So anytime you see an I squared, you're going to turn it into a negative one and multiply it by whatever it's with. Okay, so 4 times negative 1, here's 18 times negative 1 gave me negative 18. Make sense, Chad? Okay. All right, you guys do not need to write this down. Okay, I want you to just pay attention. Do not write this down, just pay attention. Okay, so we spent a bunch of time talking about solving quadratics last semester. Okay, so if I look at solving a problem like this, all right, so the way we did that was to set it equal to 0, make sure one side was equal to 0, and then we started factoring. We said, hey, my A times my C, my AC, so my A is 1, my C is negative 3. So my AC is negative 3, and I need those factors of negative 3 that add to be 2, my B value. Well, the factors of negative 3 that add to be 2 are 3 and negative 1. So there was my 3 and there was my negative 1. Then we did our factoring by grouping, and we end up down to here. Right? So we use our AC method to factor that. Okay? And then that last step to solve it was to say, what value of x would make this equal to 0, right? We set this equal to 0, x minus 1 equals 0, and say, oh, x is 1. Right? That would make that equal to 0. Or x could be negative 3, and that would make that equal to 0. Okay? So those were our solutions at that step. Okay, we solved it. So those are my solutions. Well, the thing we could do with those solutions, right, and say, well, what if I took f of 1? Well, we put 1 in, right? What would we get back out? Well, 1 squared is 1 plus 2 times 1 is 2, right? So 1 plus 2 is 2. Or sorry, 1 plus 2 is 3. And then minus 3 would be 0. Okay? So if I plug 1 in, I get 0. And the same thing, if I plug negative 3 in, I would also get 0 if we go through the math. Well, if the x value that I plug in to get 0 for y, those are called zeros. So 1 and negative 3 are also zeros. And the last thing was, if I said 1, 0 and negative 3, 0, well, those are coordinates on a graph, and those are coordinates on the x-axis. Those are x-intercepts. Hey, Ella, I will need you to get into the Google class if you haven't already. I'm guessing maybe you have since you're here. And then we'll probably have some explaining of some other things that I need to do with you. But let's see if you're there. Okay. So I know definitely something I put weight on my students, or at least I talked to my students about last semester a lot, was that we have solutions, we have zeros, we have x-intercepts. We also have this other term, roots, that all kind of mean the same thing. But right now we need to be thinking about that solutions, zeros, and x-intercepts are all really very closely related. Okay, so that when we look at the graph, we see those x-intercepts. But that means we also see the zeros, or we also see the solutions, right? But there's a connection between these three things. Okay? So solutions, x-intercepts, zeros are all very closely connected. All right? Is that clicking with you guys? Things you remember talking about last semester? And at any point something sounds fuzzy, you guys really need to make sure you're speaking up, because I'm taking this idea and we're going to start applying it now. So if this is not clear, it's going to be really hard to do the next thing. Okay? So what are we actually doing today? Okay? Here are the instructions for the problems as you're going to be written. You're going to write a polynomial function that has rational coefficients, a leading coefficient of 1, and the given zeros. Okay? So this is the question, this is the task you're being assigned. And it sounds pretty complex. It's actually not too bad. Okay? This is the main part you guys need to pay attention to. Okay? This other stuff will just kind of happen on its own. Okay? So the main thing you guys need to be worried about is you're going to write an equation or a function, okay? I'm going to write an equation that has these answers. I'm giving you the answers to the problem. I want you to tell me what the equation was that gave us those answers. Okay? When it says it has rational coefficients, that means that your answer won't have any square roots in it. You guys really shouldn't have any issues with that. Okay? And then the leading coefficient will be 1. Again, that really should kind of take care of itself. You won't have to worry about it. Okay, but I'll talk about what that would look like. Okay? So this is the way the instructions are going to be written. But it really means write the equation that has these answers. Right? I'm giving you the answers, the zeros. I want to write the equation. Okay? So these are the zeros. What's another name for a zero? Okay? A zero is also a solution. So these are the x values. Okay? So I'm telling you that x equals 0, x equals -2, x equals 3. Okay? I'm giving you those. I'm giving you these. And we want this when you're done. Okay? So we're here right now. We want to go that way. So that's our task today, is to go that way. Right? Pretty normal thing for us to do. Learn how to go one way through a problem, and then how to go back the other way through a problem. Right? How do we go the other way? Again, this is what math is more like. We don't have equations sitting around. We have things we want the equations to do. And then we have to write the equation to do those things. And then we can mess around with that equation, learn other things. So this is really what real math is more like. I want the equation to do this stuff. Give me these answers. That's the equation that's going to do that. Okay? So think about what this looks like, right? What was the last thing we had before we got these? Right? We had these sets of parentheses. This equation was factored, then we were able to solve it. So our first step needs to be going backwards to this. Well, what do we notice as we go backwards? What happens to my 1? What happens to my -3 as we go this way? Signs change, right, Brooklyn? Okay. So x equals 1, I write x minus 1. You guys got to put parentheses around it. You got to put the x in there, not just the number, right? It doesn't say -1. It says x minus 1. Right? X equals -3. That's x plus 3. Okay. So the first step is what I would say is write the equation in factored form. So you're going to go ahead and put an f of x there or whatever, okay? But each of these gets a factor. It's actually a little bit easier if I start from the right side. So 3 would go from x minus 3. -2 would come from x plus 2. 0, right? Well, I could say x minus 0, I could say x plus 0, right? -0 plus 0, there's no difference there. But why the heck would we say x plus 0 or x minus 0? What would be easier to say? Instead of saying x plus 0 or x minus 0, what would be the easier thing to say? Yep, right, Connor? Just x, okay? So you guys are going to do yourself a big disservice if you don't simplify that down, okay? So a 0 comes from a plain old x, right? Because remember what this is. The value of x that would make this equal to 0. -2 would make this equal to 0. +3 would make that equal to 0. 0 would make this equal to 0. Okay? So there's my function in factored form. There's my equation in factored form. Okay? So that's the step one. Write it back in factors. So there's a sign switch, right? You guys mentioned that. You know, we need parentheses. Okay? You know, we got to put the x's in there. Okay, so those are the things I'm thinking about as I'm writing those factors. I need parentheses. I need to switch my sign. I got to make sure I have an x in there. You know, it's not just -3. It's x minus 3. Okay, now it's in factored form. Well, what was factoring the opposite of, or the inverse of, right? When we learned factoring, factoring is undistribution. Okay, we undistributed as we went this way. Well, if I want to go back the other way, I'm going to undistribute, or I'm going to. Instead of saying undistribute, what should I say? Distribute, right? Okay. So let's distribute. Okay. Now, remember this is all multiplication here. X times x plus 2 times x minus 3. You can do it in any order you want. Okay. What you can't do when you're thinking about distribution here, you're not allowed to do this. That x doesn't distribute everywhere. I can only do two things at a time. I can take that x times the x plus 2, or I can take the x times the x minus 3, or I could take the x plus 2 times the x minus 3. I can't do three things at a time. Okay? You're only allowed to do two at a time. I would suggest, my personal habit, and what I showed you guys when you did this, you know, one of the earlier things we did with quadratics was we had something in vertex form and then we rewrote it into standard form. You guys have done math like this. Just normally there was a number here instead of a variable. Okay, but you guys have done this before. Just this idea that I told you guys to do this first. Let's do this, right? Let's do that foiling there first. Again, my personal habit. This is not the only way to do this, but that's what I'm going to do first. Okay. So that x is just going to hang out. And then we get x times x, which is x squared, x times -3, 2 times x, and -3 times 2. Okay, so I FOILed that out. Got some like terms here I'm going to combine. That x is still just hanging out there. -3x plus 2x is -1x. F of x is just following us down. Okay. And then last thing I need to do here is just distribute that x. X times x squared is x cubed. X times -x is -x squared. X times -6 is -6x. Okay. Step 1, you write the equation in factor form. Step 2, you distribute / simplify the problem, and that's it. You work it down to being an equation. Okay. So the idea here is this equation would have these answers. It would cross the x-axis at those 3 points. Okay. Notice that it has a leading coefficient of 1. That means the very first number is a 1. Okay. I didn't do anything special. It just happened on its own. Okay. So it would. Okay. It also has rational coefficients. So rational versus irrational. Irrational numbers are square roots of like the square root of 10 or the square root of 15, like numbers, non-perfect square roots, so that we don't have any square root things right here. Okay? None of these are square roots of things, okay, or pi or anything like that. So again, I didn't do anything special, that just happened. So this part here and this part here should take care of themselves as long as you set the problem upright. Okay, so you shouldn't have to worry about making that stuff happen. It should just happen. Any questions here on this one? Ella, did you get the Google class? There's that. Okay. Next one, put the link in the chat there for you. So next one is a graph. Okay. You guys don't need to draw it. Okay? If you really, really want to, what you just need is a simple set of axes. Really what you're after here is that there's a line coming down. I'm going to accentuate things a little bit so it's a little bit easier to see. Line coming down from the left. All you're really after here is that this is at -4. This one's at -1. This one's at +1. This one's at 5. Okay? We just, what we can't see is where the graph turns here, where the graph turns here, where the graph turns here, and then these sides go off up forever. Okay? So that's what's happening. So all you really need to see is this. Okay? So when you guys have that worksheet in homework, you're going to have 2 graphs like that. Again, you do not need to draw it. All you're interested in is finding these points right here. Okay? And they're all labeled. It should not be a big deal. Okay? So why give you a graph? Why is that helping us? Well, remember what x-intercepts are? They're the same thing as zeros. They're the same things as solutions. So by looking at the x-intercepts, I have this information. So it's just a different way for me to give you that information, guys. Okay? Rather than listing out the zeros, I'm giving you a graph and saying, what are the zeros? Now use them. Okay? So again, each one of these is going to get a factor. What do we have to remember to do when we write the factors? How do we write x minus 4 as a factor? Or sorry, how do we write minus 4 as a factor? So we gotta change the sign. Yep. What else do we need though? What should it look like? When we write the factors, when we write the function factored form, what should we see a bunch of? Bunch of x's. What else? Straight visualize parentheses. Yep, parentheses and x's. Okay. So x, the minus 4 becomes. Gotta change that sign. X plus 4. Minus 1 becomes. It's much easier if you guys would just talk.
X plus 1.
X plus 1. Positive 1 becomes.
X minus 1.
X minus 1. Positive 5 becomes.
X minus 5.
X minus 5, right? Who was that?
Me.
Who's me? I don't know who me is. Brooklyn? Okay, I think Brooklyn. Doesn't show me who's talking very quickly, so it's hard to know. Especially when I have to look at my iPad. Okay, you guys see how to go from the graph to the factored form? That make sense? Because that first step is so important. If you don't set it up right, there's no way to get it right after that. Okay? So remember, all that's multiplication. We get to pick where to start. We just can't do 3 or 4 things at once. We can only do 2 at a time. So it doesn't matter which ones you start with. Okay? So sometimes it's easier just to start at the beginning. Okay? So I need to FOIL those out. I'm not going to sit here and FOIL those 2 things out. You guys should be able to do that. But where you end up is x squared plus 5x plus 4. Okay? So I FOILed those out. And I still have these 2 over here. Now, the next thing I need to do is distribute again, or do, kind of like a FOIL, but it's bigger than a FOIL. Okay, but I need this green one to come, I'm gonna bring it to the black one. Okay, so that X, it's gonna distribute here, here, and here. Okay, so I'm giving an X to X squared, which is X cubed, X to 5X, which is 5X squared, X to a 4, which is a 4X. Now I'm going to distribute that -1 to all that stuff too. So it'd be -x squared, -5x, -4. Put that all in parentheses. Okay. Some people have a really hard time distributing that much stuff. And if you do, I want to show you a different way to do it on the next step. Okay. There's a lot going on there. I do have some like terms I need to combine before I move on. (5x squared minus 1x squared) would be 4x squared. 4x's minus 5x's would be -1x. Okay. You guys tracking with me so far? So if you really don't like this, okay, where I did a binomial times a trinomial, you found that really confusing to make sure you get all of these. A lot of people struggle with this. Okay, there's a different way to do this. I'm going to take this binomial times this 4-term polynomial. Okay, I'm going to do it in what's called a lattice or a box or a rectangle method. So I'm taking all this, okay, and I'm bringing it to this side over here. So what I'm going to do is I want to draw a rectangle that's about 2 lines high, okay, because I have a binomial here. So I'm making it 2 high, and I'm going to make it 4 long. Okay, you get an idea what I'll mean when I finish it. I want it 2 rows high, and I want it 4 columns long. So I did a 2x4 rectangle. Okay, that x minus 5 is going to go on the side. Make sure you put your sign there, x minus 5, and then the x cubed plus 4x squared minus x minus 4 is going to go on the top. Okay, this is just a different way of doing the distribution. It's more organized. Some of you guys might be happier with a more organized approach to this. I could have done this same thing here. I would have just drawn a 2x3 box. Okay. Within each box, I'm just going to do the arithmetic or the multiplication. So x times x cubed would go right here. X times x cubed is x to the 4th. Right? The exponents add. 1 plus 3 is 4. X times 4x squared. Well, that'd be 4x cubed, and it's positive 4x cubed. So I'm going to make sure I put my plus there. I always put my pluses when it's like that. I don't want to forget what sign that is. Okay. X times -x would be -x squared. X times -4 would be -4x. Okay, so I'm doing the exact same thing if I just distributed that x like that. All right, that x is just gonna, I'm just doing it in a more organized way. That's all it is. Okay, if you feel like writing them all out like this, go for it. It works. All right, it's just usually what we see is a lot of times people will skip, they'll like completely miss one as they're doing all these little arcs. They'll completely miss one, or they'll do like one of them twice. Okay, this forces you to really see everything like as individual multiplications. It's really hard to skip or anything or double up anything when you're doing this rectangle method. Okay, it's just a different method of doing the exact same math. Again, it's organized. It's the same reason I tell you guys to do the sock method for reducing radicals versus just like a random tree. Okay, it's just about keeping your math organized, and it generally makes it easier for people. Okay? It's not that they can't do the math, they just lose track of things. Negative 5 times x cubed is negative 5x cubed. Negative 5 times 4 would be negative 20 x squared. Negative 5 times negative x would be positive 5x. Again, I'm putting that sign on there. I want to really highlight to myself that's a positive 5. And then negative 5 times negative 4 is positive 20. Okay? Then just like last time, we go through looking for like terms. We got some x cubes. We got some x squareds. We got some x's. So I need to combine all those. So I have that x to the fourth at the very front. Positive 4 minus 5 would be negative 1, so minus x cubed. Negative 1 minus 20. Negative 1 minus 20 is negative 21 x squared. Negative 4 plus 5 is positive 1 x's. And I have that plus 20 there at the end. Make sure that you're not getting confused with what we did on Friday with the exponents, right? On Friday, we were multiplying things, and then the exponents were adding when we were multiplying. Okay, when it said multiply, we added. This is saying add these. Okay, the variable doesn't change. How many of them we have changes. Right, the coefficients are changing when we add and subtract. Right, it's still x squared, but now I have negative 21 x squared. Right, so don't mess up something you guys have known for years, which is just combining like terms, because we did something different on Friday. Okay, notice how the exponents are not changing here. Multiplication made the exponents change. Okay, notice that the coefficient is 1, right? There's a 1 right there. We don't have any square roots of weird numbers anywhere here, right? I didn't do anything special to make that happen. It just happened on its own. Okay, so it still fits those little rules that it was asking us to fit without us having to worry about anything. So this function here would have those answers that we wanted. Notice how there were 4 answers. Look at our exponent, right? X to the fourth. There were 3 answers. Look at our exponent, x cubed. There were 2 answers. Look at our exponent, x squared. Okay? Fundamental theorem of algebra. How many answers there are? Highest exponent every time. Okay? So I wouldn't say there's anything particularly difficult that we're doing here. There's just a lot of stuff, right? You guys have distributed so much in your math careers, right? In your little math lives. But it's just a lot of distribution, right? When we're doing distribution, there's just lots of little places you can make mistakes. It's mainly signs and mainly like little arithmetic errors, right? Like 5 plus 4 is 8, like something, or something like that, right? So you just need to make sure you're going slow, so you're not making sign errors, making arithmetic errors. But the math itself is stuff you guys have done over and over and over and over again. It's distribution. Okay? So there shouldn't be anything particularly difficult here. It's just make sure you're not rushing. Yeah, anytime there's an x value, it's an answer, right? 0 is one of our answers. So that gives us, right? That gave us an x, which gives us an x, cubed down here. So each one of these x's, each one of these answers gets its own factor, and then all those factors combine to give us this. There is no x. What do you mean? Are you talking about in this one? Oh yeah. Well, what should x? We don't put x plus 0, right? We put what? We don't say x plus 0. What do we say? Yeah. Okay. All right, last one. So what if some of the answers are imaginary? right? You guys have solved equations, gotten imaginary answers. Well, how do I write an equation that has imaginary answers? Okay, so it starts off the exact same way as the other ones. First thing we do is write it in factored form. So -1 becomes x plus 1. 2 becomes x minus 2. 3i becomes x minus 3i. Okay? And then -3i becomes x plus 3i. Okay? So we treat them just like they were 3's. Okay? Let's have x plus 3i, x minus 3i. Okay? Remember, we get to decide where to start. We get to decide which ones we want to multiply first. I will tell you guys that you always want to start with these. It may seem counterintuitive. You may want to save those for last because they're going to be messy or something like that. You don't want to save them for last. You want to deal with these first. Okay? So foiling that, we get x times x, x squared. X times positive 3i, we get positive 3ix. Negative 3i times x would be negative 3ix. And then negative 3i times positive 3i would be negative 9i squared. Does that make sense how I got that?
So do you want to do them first because they have i's in them, or just because they're the last ones in the equation?
I'll show you in just a sec why we're going to do first. I'm picking the ones with the i's in them, not because they were last. I'm picking them because they do have i's, yes. But the reason I want to do them first will be apparent here real quick. So those two will cancel, right? 3i and negative 3i. And then we take this. What's negative 9i squared equal to? So remember, that's equal to negative 9 times I squared, which is negative 9 times negative 1. So this is really equal to positive 9. So we take that negative 9I squared, and it becomes positive 9. And so why I wanted to do that first is now that I did that, it's just equal to x squared plus 9. So we've taken that problem that had multiple i's in it, and now it has no more i's in it. And the rest of it should be pretty straightforward. The x minus 2 is going to drop down. The x plus 1 is going to drop down. And the rest of this is going to be just like what we just did. Okay, you just need to sit here and distribute. But I mean, that's, I can do that, but again, that shouldn't be a big deal for you guys to sit there and distribute a bunch of stuff. But this is, what could be new for you guys, should be new for you guys, the idea of how to combine these and end up here. Is there anything you guys need to clarify here? I did, Jed. I tried to address it earlier. Maybe you didn't hear me. If you miss those, you just miss them. There's no way to make them up. Remember, they don't count against you. They just won't count for you. Any questions here? Again, you guys get to decide how you want to do this. If you want to take the red and the blue one and put them together, if you want to take the black and the blue one and put them together, black and the red, it really doesn't matter. Okay. I'm just going to put those two together just because that would give me x squared minus x minus 2 when I was done with it. Okay, I'm not going to step through and do the FOIL with you. Okay, if you FOIL that out, you'll get there. And then you might want to do a box method for this one. So you may want to draw a 2x3 box. I saw that Brooklyn, you said you liked that a lot better. So draw a 2 by 3 box. X squared plus 9 on the side. X squared minus x minus 2 on the top. Then sit there and do your distribution. Okay. I'll write out the answer, but I know we're running out of time here, but we should end up with x to the 4th minus x cubed plus 7x squareds okay, so that's what your answer should be when you're done doing your distribution, doing your box. But I just don't have time to do it, so. Okay. You guys have what you need in the Google class. Okay. Make sure you get your homework turned in today if you want me to grade that, and then if you haven't done the flip grade yet, then try to get that done. I'll keep watching those. You guys have 20 minutes if you haven't done the daily points thing yet. Okay, you got 20 minutes to get that turned in. Connor, so what I end up with is negative 2x squareds here. And then I'll have 9x squareds from this one. So the negative 2 and the 9 end up combining to give me this. So again, I need to fill this out. So. All right. Should see you guys tomorrow. Hopefully this is pretty easy. You're gonna have that worksheet there. Take a picture of it, submit it. Let me know if you guys have any problems. Enjoy the rest of your days.